Greetings, fellow explorers. Today, we are setting off on an incredible journey that will take us deep into the fascinating world of machine learning. You are about to embark on an incredible journey, one that will open your eyes to the endless possibilities of technology and innovation. This is the journey of machine learning, a field that is revolutionizing the way we interact with the world around us. It is a journey into the heart of artificial intelligence, where machines are not just tools, but intelligent entities capable of learning and evolving. Machine learning is about teaching computers to understand and interpret data, enabling them to perform tasks that were once thought to be the exclusive domain of humans. We teach them to learn from data, to recognize patterns, and to make informed decisions based on the information they process. This lets them make predictions about future events, trends, and behaviors, providing valuable insights that can drive innovation and progress. It also lets them make decisions, automating processes and improving efficiency in ways that were previously unimaginable. It's like giving machines a brain that can grow and adapt, continuously improving their performance as they learn from new data. Our journey begins with Python, a versatile and powerful programming language that is widely used in the field of machine learning. Python is a powerful language, known for its simplicity and readability, making it an ideal choice for both beginners and experienced programmers. It is the language of choice for many scientists and engineers who use it to develop complex algorithms and models that drive machine learning applications. It is perfect for exploring the cosmos of machine learning, allowing us to delve into the intricacies of data analysis, model building, and predictive analytics. Are you ready to begin this exciting adventure? Let's go. Together, we will unlock the secrets of machine learning and discover the incredible potential it holds for the future. Every explorer needs a reliable spaceship. For us, that spaceship is Anaconda. Anaconda is a platform. It comes with Python and many useful tools. First, download Anaconda. Choose the version that matches your operating system. Then, install it like any other program. It's like preparing your spaceship for a long voyage. Once installed, open the Anaconda Navigator. You'll see a dashboard with various tools. Launch Jupyter Notebook. This is where we'll write and run our Python code. Congratulations! You've just built your very own data science laboratory. Now the real exploration begins. Imagine learning a new language. Python is similar. Just like any language, it has its own set of rules and syntax that you need to understand. We need to learn its grammar. This includes understanding how to structure your commands so the computer can interpret them correctly. We need to learn its vocabulary. Python has specific keywords and functions that you need to become familiar with. In Python, we use commands to communicate with the computer. These commands tell the computer what actions to perform. A simple command is print. This function allows you to display messages on the screen. Type print, "Hello universe," and hit enter. The computer responds. It will display the message you typed within the parentheses. It prints "Hello universe" back to you. This is a basic example of how you can interact with the computer using Python. You just had your first conversation with the machine. This is the beginning of your journey into programming. You can also do math with Python. It can handle simple arithmetic as well as more complex mathematical operations. Try typing 2 plus 2 and see what happens. The computer will calculate the result for you. Python is a powerful calculator. It understands mathematical operations and can perform them quickly and accurately. It can help you analyze data and make calculations. Whether you're working on simple math problems or complex data analysis, Python is a versatile tool that can assist you in many ways. Our programs need to make choices. They need to repeat tasks. This is where control flow comes in. If statements let your program make decisions, if the temperature is greater than 30, print, "It's a hot day." For loops, repeat actions multiple times. For example, for I in range of 5, print, "This is loop number I." These tools give your programs logic and flexibility. They are the building blocks of intelligent behavior. Section 5. The power of organization, lists and dictionaries. Imagine a vast library. Books are scattered everywhere. It would be chaotic. We need ways to organize data. Lists do just that. They store data in an ordered sequence. Planets equals Mercury, Venus, Earth, Mars. Dictionaries use key-value pairs. Think of a real dictionary. Words are the keys. Definitions are the values. Planet data equals Earth 1, Mars 2. These structures keep your data tidy and accessible. Just like a well-organized library makes finding information easier. Section 6. Building your own tools. User-defined functions. Imagine writing the same code over and over. It would be tedious, right? Functions are like reusable tools. They let us write code once and use it many times. Here's how to define a function. Python def greet name. Print hello name plus greet earthling. Now we have a function called greet. It takes a name and prints a greeting. Functions make your code more efficient and organized. Section 7. The Galactic Library, NumPy, Pandas, and Matplotlib. We've learned the basics of Python. Now, let's explore the vast libraries it offers. Libraries are collections of pre-written code. They save us time and effort. NumPy is our math library. It handles arrays, matrices, and mathematical operations. Pandas helps us work with data. It provides tools for data analysis and manipulation. Matplotlib lets us visualize data. It creates beautiful charts and graphs. These libraries are essential for any aspiring data scientist. They are your companions in exploring the universe of data. Section 8. The Language of the Cosmos. Math for Machine Learning. In this section, we will delve into the mathematical foundations that power machine learning algorithms. These concepts might seem daunting at first, but with a bit of patience and practice, you'll find them to be quite intuitive and essential for understanding how machines learn from data. Behind the scenes, machine learning relies heavily on math. From linear algebra to calculus, these mathematical tools are the backbone of machine learning models. They help us to create algorithms that can learn from and make predictions based on data. Don't worry, it's not as scary as it sounds. We'll break down these concepts into manageable pieces, making them easier to understand and apply. We'll focus on the essentials. Vectors are like arrows. They are fundamental in representing data in machine learning. They have direction and magnitude, which makes them incredibly useful for representing data points in a multi-dimensional space. Understanding vectors is crucial for grasping more complex concepts like vector spaces and transformations. Matrices are grids of numbers. They are used to represent and manipulate data in a structured form. In machine learning, matrices are often used to perform operations on datasets, such as transformations and rotations. Linear equations describe relationships between variables. They form the basis of many machine learning algorithms, including linear regression and support vector machines. By understanding linear equations, we can model and predict relationships within our data. Statistics helps us understand data patterns. It provides the tools to summarize and interpret data, making it easier to draw meaningful conclusions. Concepts like mean, median, variance, and standard deviation are fundamental in analyzing data distributions. Probability deals with chance and uncertainty. It allows us to model and quantify the likelihood of different outcomes. In machine learning, probability is used to make predictions and to understand the confidence of those predictions. Correlation measures relationships between variables. It helps us to understand how one variable may change in relation to another. This is particularly useful in feature selection and in understanding the dependencies within our data. Regression helps us predict values based on data. It is a powerful tool for modeling the relationship between a dependent variable and one or more independent variables. Techniques like linear regression, polynomial regression, and logistic regression are widely used in machine learning. These concepts may seem abstract, but they are the fundamental forces that govern the behavior of data. By mastering these mathematical principles, you'll be well equipped to tackle complex machine learning problems and to develop models that can learn and make predictions with high accuracy. So, let's dive in and explore the fascinating world of math for machine learning. Section 9. Keep exploring the universe of knowledge. Congratulations! You've taken your first steps into the fascinating world of machine learning. You've learned about Python, libraries, and essential math concepts. Remember, this is just the beginning. The universe of data is vast and ever-expanding. Keep exploring, keep learning, and most importantly, keep asking questions. The cosmos of knowledge awaits you.